So one last example for chapter 7, one last example pretty much for all of first year calculus. So you can imagine what is going to happen next. What if we combine those two possibilities of having our axis of revolution not be a coordinate axis and also having our region that we revolve not be flush up against that axis. So same original region as the previous problem, the area between the line y equals 2x and the parabola y equals x squared. I'm going to take that same region, and instead of revolving around the y-axis, I'm going to revolve it around the line, the vertical line, x equals 2. So there's a picture here that's nice. It would be unlikely on the AP test that they would give you a problem where you had to revolve a region around an axis that it wasn't flush to, that wasn't a coordinate axis, and that they wouldn't give you a picture. The chance of all three of those happening on the same problem. I'll go on the record saying that. So here we have a picture at least. I can imagine, I see this picture here, that if I take a slice, I have a vertical axis of revolution, so I'm going to have to take horizontal slices. The thickness is going to be a dy, a small change in the y. And I can imagine if I took that slice, there's going to be a big hole in the middle because the region between that sort of wing-shaped region between y equals 2x and y equals x squared is not, straight up against the axis of revolution, x equals 2. So I'm going to try to, draw my pictures in. Let's see. Can I do this? Oh, this is much better. Here we go. So I'm going to do what I do. I'm going to make the axis of revolution red. It was already kind of red. I'm going to use my green pen. I'm going to try to draw a slice. So when I draw the slice, I'm going to start my pen. Well, this time I have to draw two slices. I just sort of draw a slice of the big and then a slice of the whole. H-O-L-E. So let me, and when I draw, I'm going to draw toward my left-hand side because that's the side where I have my functions are labeled with their functions. So if this was R, this is going to be the reflection of R. I'm going to draw toward the original region R. So here's my slice of the whole. Zoop. Here's my slice of the hole on the inside. I'm going to try to draw my radius now. So I'm going to go from the axis of revolution toward the far edge. In this case, the left far edge, because that's where I have curves that are marked. And then I'm going to do something similar for the... There we go. So if I can write an expression for capital R, an expression for little r, I'm pretty much going to be ready to write my integral. So capital R, this capital R is a horizontal line. I'm going to have that same problem I had in the last example, where when I try to find the distance of a horizontal line, I'm going to have to subtract x minus x. But notice neither of my curves is solved for x. So I'm going to come through here and I'm going to note that the square root of y equals x. That's the curvy curve, the parabola curve. And y over 2 equals x. That's the linear curve. So I know when I bump into something which one I'm talking about. So capital R, I started my line, my blue big radius, at the line x equals 2. And I ended bumped up against the line y equals 2x, which I'm going to think of instead as x equals y over 2. So that's the subtraction problem I'm going to do. I'm going to start with 2 and I'm going to subtract y over 2. That's going to be my capital R. My little r, I started my radius in the same place at x equals 2. And I bumped into the curve y equals x squared, but I'm going to think of that as x equals square root of y because I need an expression for the x coordinate. So just notice this pattern. Only notice if it helps you. But when I have washers, and I'm gonna not have the a coordinate axis as my axis of revolution. Notice that that number that comes from the equation for the axis of revolution shows up typically in both your radii. So I'm not surprised that I saw 2 in both of those, because I started my pen in the same place when I drew both of those blue radii. So now that I have this expression, I know I need an integral in terms of y. My y coordinates, so the same problem as the last problem, right? My smallest y is 0, my biggest y is 4. So I'm going to write pi, the integral from 0 to 4, capital R squared dy. Capital R is 2 minus y over 2. 2 minus, I'm going to rewrite that so it looks more like a y. Y over 2 squared minus, so that would have been, if I'd filled in, if I like stuffed putty in the middle of that surface and then tried to find the volume into the middle of that solid and then tried to find the volume of the whole solid, this is that volume. I'm going to subtract out the volume of the whole, HOLE, the air in the middle. And it's going to be pi times the integral from 0 to 4 of little r squared dy, and little r in this case we said was 2 minus square root of y. Final answer.